In this video, we'll walk through adding autofocus functionality to a UI. So when an element of the UI is clicked, it will smoothly center to where we want on the screen at the speed and curve that we choose. First, we'll add the variables to our interfaces that we're using to communicate within the system. Then we'll add the variables to the component that we're using to control everything, piping them into that interface. And lastly, we'll create the blueprint functionality in the skill tree UI to center on a clicked element of the UI. So we'll start in the Skill Tree Pro MISC data folder, opening up the Skill Tree PC component, the interface. And we're going to add 4 outputs to the get tree info interface call. The first one will be called autofocus selection. And the second one, autofocus offset percent. Node centering curve, and node centering duration. And these variables will give us complete control of how the autofocus happens. The autofocus selection is a bool. Autofocus offset percent is a vector 2D. Node centering curve is a runtime float curve. And node centering duration is a float. Now that these are in here, we can compile and close this. And next we're going to open the component which controls everything. So in components, I already have it open, but we're going to navigate to the get tree info interface call. So in interfaces, STPPC internal, get tree info, and we can see our new variables here. And we can just right click promote to variable for now, all of them. And let's compile. And we'll set some of the defaults. The autofocus selection, we can default to true so that we see the functionality right at the start. The node centering duration, we can change to 0.4. The autofocus offset percent, we'll set to -0.2. 0, and we'll see why we're doing this later. We don't want it to focus on the exact center of the screen. And in the slider range and value range, we can also add things for designer convenience, -0.5, 0.5 to both. We can do the same for node centering duration if you want. You can add 0 to the minimum for both, just for designer convenience. Now the last defaults we need to set are on the node centering curve. I've found that this is real finicky and buggy if you do it here and then even try to tweak it, override it in the child component. What you really want to do to get this working is create an external curve. So you can expand this here, create external curve. I've already created one. You just right click and add keys to the graph. You want to add your first key to 0, 0, your last key to 1, 1, and then you can select, right click the keys and make them auto. And then when you do that, the line will curve. Then you can add 1 key to the middle here and set it however you want. So the curve is set here. So we can simply advanced display that and even make it private. And the last thing I want to do is actually change these last 2 names so they're all starting with autofocus. So when we come back in here, it'll just kind of make more sense. So we'll call this autofocus curve and autofocus duration. And let's drag these all into the tree behavior section. I kind of want to reorder these variables so that they're in a different order in the child component. Now we're done in here, we can compile and close this. And the last thing we want to do is go into the widgets folder and open up the skill tree base widget. And the first thing we'll do in here is in our functions, procedural tree generation, we'll open up the catch skill tree component and info, and we're going to catch these new variables that we're getting. And we can simply right click and promote them all to variables and then connect them to the execution. And we can drag them into the node autofocus category. And we can close that. And now in the event graph, we're going to make a new event and we'll call it center on clicked node. And we will input the node location where we want to center to. And this is a vector 2D. And when do we want to call this? We can call this when we select a node. So under functions, nodes, in the node selected function, we left an execution pin here. We did that just so we could call this center on clicked node. And in this function, we're inputting the node position here, so we can just get that. And now back in this function, this is only going to run if autofocus selection is true. So to center on a clicked node, we're going to simply slide the tree widget to a new location. Since everything is attached to it, everything will slide and it will have the effect of looking like a camera is panning over the widget. To do this, we need to calculate the starting and ending translation of the tree widget, and then lerp it to the new translation on a timer. We're going to make two more vector 2D variables, an autofocus starting translation and an autofocus ending translation. And they're vector 2Ds. We can drag them into the node autofocus category. And here we're going to set both. So first we'll set the autofocus ending translation, dragging off true. And to do that, we're going to get the node location, negated 2D, and we're going to add splitting this, and we'll get viewport size, split it, and we're going to multiply both of these. We can copy and paste this, and also add a pin to both, connecting them here. We'll multiply them by the autofocus offset percent. You can split that. X goes into X, Y goes into Y. And under references, we'll drag in the node canvas, and we'll get the transform. And we can split this, and we'll split the scale. We're going to use a safe divide here. And we're going to say 1 divided by scale X. We can copy and paste the safe divide, 1 divided by scale Y. And we're going to plug the X into the X and the Y into the Y. And we can plug the whole thing into the autofocus ending translation. Now essentially what this is doing is it's just translating the widget over. If autofocus offset percentage is 0, all of this doesn't even happen. So it's just negating 2D the node location. But if the autofocus offset percentage is something, that's the percentage of the screen over that it's going to go on that axis. So if it's negative 0.5 on the X, it'll go over from the center negative 0.5. And we'll see exactly how this works a little bit later. For now, we'll calculate the autofocus starting transform, and this one's going to be a lot simpler. Drag in the node canvas, get the transform, split it, and we'll set the autofocus starting translation just from the transform translation that it's already at. And here we want to get game time in seconds, and we can promote this to a variable, and we'll call it autofocus starting time. Drag it into the node autofocus category. And before we run our timer, we're going to clear it out. Now we're going to set timer by event, dragging in that timer and setting it here. And we're going to set up the timer to run on tick until it's finished. So a very small time, looping, max once per frame. And on the timer, we're simply going to set the render translation of the node's canvas. Translation, not transform. And here we're going to calculate the translation. So we're going to right click, lerp vector, and we can plug it into here. And we're going to split the A and the B. Take the autofocus starting translation, split that, plug them into AX and AY. Take the autofocus ending translation. We're going to multiply this to something. We're going to split that, plug this into BX and BY. The thing we're going to multiply it by is the node canvas, transform, split, scale. And what this does is it makes sure that this system works with the zooming system that we created earlier. Because remember, there is no camera. We're simply zooming to make it seem like the camera's zooming in and out. Now to calculate this alpha, which is how far along it is from its starting location to its ending location, let's make a new function. Call it get node centering progress. We get a pure function and we'll return a float. We can just call it return value. And we only want to run this if the skill tree component is valid. We're going to get the node centering curve and the node centering duration. And for the node centering curve, we're going to get runtime float curve value. And we're going to return that. The default can stay 0, but for the in time, we're going to get game time in seconds, subtract that from the autofocus starting time, and we'll do a safe divide by the node centering duration, and we'll plug that into the in time. And what this is saying is, how far along the curve are we? We are how much time has elapsed divided by the overall time that should elapse during the process. The percentage of that is how far along we are in the curve. So now we can go back to the event graph and we can drag in the get node centering progress and plug that into the alpha. I also want to add this to the camera section here. So we're setting the render translation now. And then after doing that, we want to drag in the get node centering progress. And if it's greater than or equal to 1, that means that it's finished. If it's finished, we're going to stop the timer. So stop this operation from running. And we can comment this whole thing. We'll call it center on clicked node. So now when we fire up our game and we click on nodes, they center right to this exact location on the screen in a nice smooth way. And the reason they do that is because we set the autofocus offset to -0.2 on this axis. This is 0, 0, the center of the screen, -0.5 over here, +0.5 on the right. And so the reason we did that is so it doesn't half go under this widget here. It's kind of just out here in the open space. And we can play around with that. We can also play around with the feel of the curve and the duration. It's currently set to 1 second, but if we want to, we could close this, and over in the child component here, we now see the autofocus duration. We could set it to something like 0.4, and we can play around with the curve if we want. And then when we fire it up, we click on a node and it's nice and snappy. So we have a lot of control over the feel of this system and how it will autofocus exactly. And we'll also see that it works regardless of how zoomed in we are. It still autofocuses to that exact point in the screen. So in this video, we created an autofocusing ability for our skill tree. In the next video, we're going to create a persistent saving system so that when the entire game is closed and reopened, it will remember which skills have been trained and how many research points are still available.